So coming to the course objectives, it is to develop understanding among the student about the fundamental concepts of reinforced concrete design, uh, design philosophies, codes involved uh, or in the design of reinforced concrete members, and different safety provisions which need to be considered, and then enabling the students in analysis and design of different type of reinforced concrete members, which may include beams, one-way slabs, and axially loaded columns. So the course learning outcomes, which includes uh, concepts of reinforced concrete design, design philosophy. So at the end of this course, the student should be able to demonstrate the concept of reinforced concrete design, and they should have knowledge of different design philosophies and loads and safety provisions which must be considered in case of designing these members. And they should be able to analyze and design um, different types of reinforced concrete beams like rectangular beams, T beams, L-shaped beams, and they must be designed for shear as well as flexure, and then uh, design of one-way slabs and axially loaded columns. For achievement of these objectives, different teaching methodology and learning activities will be conducted during the course of time, uh, which may include video presentations, which we are going through right now, solve examples, in-class activities and classroom discussions once we are back to class, home assignments, quizzes, take-home tests, midterm, and final term examinations. So these will contribute to the learning as well as the assessment of this course. Regarding assessment, 25% of the graded marks will be contributed by the quizzes, homework assignments, and to take-home tests. 25% from midterm examination, and 50% will be contributed by the final term examination. It will cumulatively uh, go towards the gradation of this course and achievement of the uh, objectives. Coming to the course outline, it consists of 9 chapters. Chapter 1 is related to the introduction of reinforced concrete, uh, advantages and disadvantages, applicable codes, loads and safety provisions, and then properties of concrete which include compressive strength, tensile strength, flexural strength, Poisson's ratio, and different factors affecting these properties of concrete. Chapter 3 is related to the analysis of reinforced concrete beams and different factors which must be considered to analyze beams like rectangular and T beams. Then chapter 4 deals with the design of uh, reinforced concrete beams for flexure as well as shear. Then coming to deflections in these reinforced concrete beams, which may be short-term deflections as well as long-term deflections, development lengths which are necessary to develop the full capacity of embedded steel. So they must be properly developed. So knowledge related to development length in tension, compression, bond strength of steel in concrete, then coming to design of one-way slabs as well as axially loaded columns. So this all will contribute to achievement of this course. These are the recommended books which you can follow for additional knowledge acquiring. If you have any problems, you can always contact me to clarify them. I will also be uploading notes from time to time, so you can follow them as well. So, starting with the introduction of reinforced concrete. First of all, what is concrete? It is a mixture of fine aggregate in the form of sand, then coarse aggregate, which may be natural or crushed aggregates, and then cement and water is added to, they are mixed in specific proportions to come up with the concrete, and some admixtures may also be added for additional purposes. So admixtures in normal cases are not added into concrete, but if some specific properties are required out of the concrete, different types of admixtures may be added, which may be set retarders, accelerators, air entrainment admixtures, superplasticizers, color pigments. So we'll discuss different types of admixtures in the coming slides. So compressive strength of concrete is very good. However, compared to it, its tensile strength is very low. Normally, tensile strength of concrete is almost 10% of its compressive strength. So, to compensate that, steel bars are added on the tension face of the concrete members to take tensile stresses. So the compressive stresses are taken by concrete and tensile stresses are taken by the embedded steel bars. However, steel can also be used to take compression in case of columns, or in case of doubly reinforced beams in which steel bars are also added on the compression phase of the beams to take additional compression or to increase the compression capacity of those members. So we'll be discussing all of them in our course. Coming to advantages of reinforced concrete, they have high compressive strength relative to unit cost. So the cost per unit compressive strength is very low. They have high resistance to fire and water compared to steel construction. Reinforced concrete structures have high stiffness compared to steel, which are ductile, and thus they have low vibrations. They have lower maintenance cost. Reinforced concrete structures have long service life, and they are often economical for different types of applications. And as they are in plastic form, when they are mixed, they can be molded into any shape. So they provide architectural flexibility. They can be molded into any shape as per architectural needs. As 60 to 70% of the concrete is composed of aggregates, which may be fine aggregates or coarse aggregates, and they are mostly locally available. It is the ease of availability of the material as well as its cost, because when it is locally available, its cost is also lower. And the requirement of skilled labor in case of reinforced concrete construction is lower compared to that of steel structures, where highly skilled labor are required for erection purposes. Reinforced concrete construction also offers some disadvantages compared to the other structures, other type of structures, which first of one is the lower tensile strength, which we have already discussed, because of which steel bars are added into it. Then because the concrete is in plastic form in initial stage, it cannot support its own weight. So temporary structures and formworks are needed to support them till the time they have acquired sufficient strength to support its own weight and some additional construction weights. So uh, this requirement of formwork and false work um, may incur additional cost, and in some cases this cost may be quite high, so it makes construction a bit expensive. And they have lower strength compared to its unit weight when compared to steel, uh, taking equal weight of both steel and concrete. Concrete provides lower strength compared to steel. So because of this lower strength to unit weight ratio, um, heavier sections of concrete are required during constructions, which increases the self weight of the structure, and thus when self weight of structure is increased, it induces additional stresses into the concrete. So the stresses induced in the structure because of its own weight are quite high. Then because of heavier section, you may require taller buildings, because if for some specific purpose we need 10 feet clear height of story, but if there is a heavier beam which is itself 2 feet in depth, so it reduces the clear spacing, so you might need 12 feet high story to come up with the clear story height of 10 feet. So it increases per story height, which increases the total height of the building. Uh, Concrete properties can vary widely depending upon the proportioning, mixing, and curing. Thus, on site, it uh, depends upon the workmanship. If poor workmanship is followed on site, if the mixed composition of concrete are varied, if more water is added into the concrete, if lesser cement is added, it will uh, be subjected to a wide range of uh, uh, changes in its final compressive strength or final strength of the members. Thus, they are dependent upon the workmanship. Thus, quality control may be limited or when compared to steel construction, which are casted in factory in a quality controlled environment. So variation may be higher, a lot higher compared to steel structures. Coming to the codes which will be followed for designing of reinforced concrete members, we'll be following American Concrete Institute code ACI 318, which is the building code requirements for structural concrete, and then ASCE 7-10, which gives the requirement for loading of different types of structures. There are other codes also followed. Commonly used are Euro codes, which are followed in Europe, and then DIN code, which is followed in Germany. So coming to different types of cements which are used in the production of concrete, uh, their properties vary. So there are different major types of cements in use, which are type 1 to type 5. Type 1 are normal ordinary Portland cements, which achieve its design strength in 28 days, and they require a minimum 14 days of curing before the formwork can be removed so that it can support its own weight and some additional construction weights. In case of type 2 cements, which are low heat of hydration cements, and they also offer some sulfate resistance. Sulfate attack is not desirable for concrete, because once sulfate compounds um, are seeps into the concrete, they form some new compounds which have more volume compared to the original volume. So they exert internal pressure in concrete, leading to cracking in the concrete and reducing their strength. So to guard against those sulfate attacks, type 2 also provides some sulfate resistance, but the major um, um, advantage is that they are low heat cements, so they have lower rate of strength development. They are mostly used in hot weather concreting, where strength development uh, where because of hot weather the flash setting may occur, or uh, which may not be desired. So to reduce the rate of strength development, type 2 cements are used, and then they are also commonly used in mass concreting, where if normal cement is used, there will be higher heat of hydration, which will cause internal cracking. So to reduce the rate of strength development and to reduce the heat of hydration, low heat cements are used so that the strength is developed slowly and gradually, and avoid internal cracking. Uh, the next type of cement is type 3 cement, which is um, high heat of hydration, produces high heat of hydration. They normally achieve their design strength within 7 days of casting. They may be used in cold weather concreting, where sufficient early strength is required before the concrete may be exposed to extreme weather, or they may also be used in different types of structures where early removal of formwork is required, and some additional construction weights need to be supported by the structure. So they have a high rate of strength development compared to type 1 and type 2 cements. However, um, 20, 28 days strength may be similar. Type 4 is again low heat cement, which is similar to type 2 cement, and they are used for similar purposes. Type 5 is a sulfate resisting cement, which we have already talked about, to avoid deterioration in concrete because of seepage of sulfate compounds into the concrete. Sulfate resisting cement must be used, and they are used when concreting is performed in water or in different types of soils containing sulfate compounds. Then coming to admixtures, which are of different types, most commonly used admixtures are discussed in this presentation. First one is air in training admixture. Air in training admixtures produces small air bubbles in the concrete. Um, they are used to avoid the deteriorating effect of lower temperature on the concrete, or when concrete is exposed to freezing and thawing cycle, because when water seeps into the concrete and then temperature falls below 0 degrees centigrade, the volume of the frozen water increases. Once the volume increases, it exerts pressure inside the concrete, leading to cracking, internal cracking. Because of these cracking, once a thawing cycle comes, more water seeps into the concrete, uh, which freezes once the temperature goes below 0 degrees centigrade. And again, additional uh, pressure is exerted, which increases the crack width and thus leading to uh, deterioration of the concrete. So to avoid this, this air entraining admixture is added while concreting. It produces air bubbles inside the concrete. They are tiny air bubbles, and when water seeps into the concrete and when it freezes and exerts pressure, pressure is diffused into those air bubbles, and thus it doesn't lead to the cracking of the concrete. So the major impact of air entering admixture is to avoid the initialization and increase of cracks in the concretes because of freezing and thawing effects. So they are important for bridge decks and other concrete members which are exposed to freezing thawing cycles in extreme weathers. Then there is another commonly used admixture which is called accelerator. Accelerator basically increases the rate of strength development of the concrete, and it can be used in the areas where um, um concrete may be exposed to freezing temperature, or where there is a low weather concreting. So the concrete must develop enough strength before it is exposed to freezing temperature. So accelerators are used so that the rate of strength development is increased in initial time of the concreting, and concrete has already gained sufficient strength so that it uh, cannot be affected by the extreme weather or low temperature uh, exposure. However, the calcium chloride, which is one of the accelerator, may cause corrosion of metal which are embedded in the concrete. The other commonly used admixture is set retarder. They have the opposite impact of that of accelerator. They reduces the rate of strength development of the concrete, or reduces the setting time of the concrete. So they are mostly used in hot weather concreting, which where setting time is reduced because of the hot weather. So to compensate for that, the set retarders are used. And then one of the major advantage of its use is when concreting is performed in different layers. So to avoid the setting of the already placed layer before the next layer is placed, and to avoid cold joint, set retarders are used so that once next layer is poured, the already placed layer is still in plastic form, and there is better bonding between successive concrete layers. So set retarders are quite advantageous in case of this type of construction. Water reducers are also commonly used at mixtures, which may be categorized into simple water reducers and high range water reducing agents. Simple water reducers are called plasticizers, and high range water reducers are called superplasticizers. So they have different impacts. First of all, because as from its name indicates, it reduces the requirement of water for concreting. So by reducing water, water cement ratio is reduced, and reducing water cement ratio has a direct impact on the strength of concrete. So by reducing water cement ratio, you can increase the compressive strength of the concrete. Additionally, if compressive strength of concrete doesn't need to be increased, quantity of cement may be reduced to achieve the same compressive strength with lower water cement ratio. Additionally, using same amount of water once requirement of water is reduced, workability of the concrete may be increased. So plasticizers may be used in three different ways to reduce the water cement ratio, which can increase the compressive strength of concrete. So it can be used to increase the compressive strength of concrete. Then it can also reduce the quantity of cement, thus it can make the concrete economical, and it can increase the workability of concrete, thus it can make placement of concrete easier. Similarly, superplasticizer are most commonly used for production of self-compacting concrete. Self-compacting concrete normally uh, uh, doesn't require any type of vibration for its compaction, because once normal concrete, which is called normal vibrated concrete, once they are placed, there are air bubbles entrapped inside, and vibrators are required to take out those bubbles and to compact concrete properly. But self-compacting concrete, they have good workability, good flow properties, so they do not require any type of vibration for its compaction, and they flow under its own weight to compact in congested areas. Super plasticizer are mostly used for production of self-compacting concrete by increasing its workability to an extent where concrete have self-flowing property. Normally, plasticizer reduces water requirement by around 15%, and super plasticizer reduces the water requirement for concreting by around 30 to 40%. So with this, we come to the end of our today's lecture.